Welcome back to Spank Ranch Garage. We are back on the 450 John Deere tonight, and I want to go over some HLR adjustments. Quick synopsis on how this works. You've got a standard clutch pedal here. You've got a standard 4-speed transmission on this left shifter. This is a collar shift transmission. Works just like a car, truck, or tractor, where you've got gears, forks, and dogs that engage it all. There's no synchros, it's unsynchronized, just like any other transmission, really. And then next to that, this shifter, you've got the HLR setup, which is the power shift or shuttle shift, whatever you want to call it. Basically, that's what enables you to shift while you're moving, and that works more like an automatic transmission. So basically, in the front of the transmission here, you have clutch drums that are full of discs, and they are hydraulically actuated, and there's some planetary gears in there to add gear reduction or reverse the direction. And then behind that is your standard 4-speed, and then you've got basically a ring and pinion back there, which would be your third member on your car, truck, tractor, whatever. So that's the basics of that. That's what this allows you to shift on the fly. This you got to stop to shift. This is how you end up with 8 forward gears and 4 reverse gears, the combination of these 2 levers. So this evening, I want to focus on 3 separate functions of this transmission. It all starts with the clutch pedal. This clutch pedal is dual function. This clutch pedal is disengaging an actual clutch disc and pressure plate assembly on the back of the engine. This is the bell housing here, kind of looks just like a normal transmission. It's actually a normal throwout bearing and everything in here. Now that doesn't actually start to engage until you've gone pretty far down the stroke. The second function of this pedal is to pull on a linkage, which you can see through this hole here. I'll try to get you guys a better picture of that. But that actually controls or dumps oil pressure from the HLR side of the transmission. So when this dozer is working properly, you can push this in probably an inch or 2, and the dozer is going to come to a stop. But the input shaft of the main transmission is still coupled to that clutch up there. Not until you entirely depress this does that actually fully disengage. So let's get to adjusting that as per the manual. Your first adjustment for the free play is right down here at the bottom of the clutch lever, or the clutch pedal. And by moving that bolt in or out, you will change how close the throwout bearing is to the pressure plate depending on pedal position. Second function is looking through that hole. Okay, so now looking through the hole in the top of the transmission, you can see that when I push the clutch, you can actually see the throwout bearing going in and out in the top left corner of that hole. And you can also see the HLR lever going up and down. And on top of that, there's another adjustment point there. So just like everything on this machine, the adjustments need to be done in a way kind of like the manual says, but there is some room to wiggle. You just got to realize that every adjustment affects other adjustments, and this clutch pedal is no different. They'll walk you through the procedure here of how you adjust the free play on the pedal, and then you'll adjust the HLR side of it. And then we'll actually get into pressure tuning once that's close. I do want to show you just how that looks inside the bell housing though. So it's not all that complicated in there. Clutch pedal turns this shaft right here, which has a return spring on it, and then it has this fork. And this fork presses on a throwout bearing. If you've been in transmissions before, this is all familiar to you. The only real difference is it has this tab off the back here. And this tab, as this rolls forward, this tab moves upwards. And that's what actually drives this hydraulic valve on the HLR transmission. So as you adjust that clutch pedal, this is going to move up or down. So if you make clutch pedal adjustments or you move that fork forward or back, you need to readjust this to make sure it's in the position it wants to be. And this valve is very critical to how it shifts between forward, reverse, high, low, all that kind of stuff. So if things really bang in gears, you're going to want to take a look at this. And if you're going to do any adjustments to the pressure on the HLR trans, you need to make sure this thing's spot on before you go play with anything. So the first thing is the pedal free play. This is supposed to be 3 3/4 inches of free play before you actually hit the pressure plate. And I drew a line back here to indicate 3 3/4 inch, and it's way off. So that's my first problem. Second problem, this bolt is totally bottomed out. I can't get any more adjustment out of it to actually fix the free travel on the pedal. So what's going on? Well, it's possible somebody had this engine out at some point and didn't set up the fingers on the pressure plate correctly. We're just kind of out of throw. The clutch does work. It does touch when you're, before you actually pound the pedal into the firewall, but it needs to be moved up quite a bit. What I'm going to try is remove this bolt and put some washers under it to shim it up to get a little more throw out of that throw out bearing fork, and we'll see if we can get closer to spec. And I want to put some washers underneath this here just to get us by. Put 3 1/2-inch washers on there. Bring that up. That should give me plenty of adjustment, I hope. The thing that intrigues me about this is that as the clutch wears, you would be backing this bolt off, not turning it in. So to run out of travel the other way, it's either like someone had this apart, didn't put it together right, or it's straight up missing a part, and that's very possible. I'll have to look at a parts breakdown and see. But either way, the correct fix is to pull the engine out, and that ain't gonna happen for a clutch that I don't actually use. But I want to get it a little closer and see if we can cheat it a little bit, and I might get another 15 years out of it, who knows. There it is. So that is the correct amount of free play according to the manual. I drew a line down that extension socket. It's a 1/2-inch. Now you got to trust your extension, because if you lift this out of here and that socket falls off, it's going down in the bell housing and it's going to reside there for a very long time. So work slowly, intentionally, and carefully with that one. According to John Deere, I'm supposed to turn this thing inwards, turn the stop nut down until the clutch pedal starts to pull away from the stop. This is the stop down here, the hard stop on the bell housing. So we will turn that down until it starts to crest off of that. Okay, so the adjustment has backed the lever off of the stop, so I'm going to start to creep it back. You'll see that clutch lever coming back, clutch pedal. Okay, so that is just touching now. When you get to this point, you're going to back it out 5 turns, and that's going to be a starting point for us for pressure tuning. 1 turn, 2 turns, 3 turns, 4, and 5. So that is back to factory setting, and it's just a ballpark. And now we're going to fire this up, do some pressure checks, and see which way we go. Alright, so let that idle about 15 minutes, and the transmission is warm. Heats up really quick. Hope it's not foreshadowing for some other issues. Anyway, to the pressure test, let's get this drum plug out of the middle here. This needs to be tight, as I said in my transmission video with the water in there. I think this is how these transmissions get water in them, if I had to guess. So I used an 1/8-inch pipe to Schrader valve adapter, and that way I can use a standard fuel pressure tester gauge for a gasoline car. I did put a different gauge on it. This one reads to 250. That should be enough for this. Really 200 would be enough, assuming this thing's not overpressured. We're going to start this, and then we're going to start to turn that linkage, the HLR linkage in the bell housing. We're going to start to turn that clockwise slowly, and we'll be watching the pressure on the gauge come up. And then as the nut is turned, pressure at the gauge will increase to a maximum, then drop as the nut is turned further. From the point where a 5 to 10 psi drop occurs, continue to turn the nut 1 complete turn counterclockwise. When properly adjusted, pressure at the gauge should rise 5 to 10 psi when the pedal is depressed to 1/2 to 3/4. right, we're getting somewhere with this. That clutch pedal tuning was pretty touchy. I really had to play with it to be able to see that small, I'm only getting about 5, maybe not even 5 PSI bump before the pressure dumps. And that's what they want on the clutch pedal. They want that first ½ inch of clutch travel to just bump the gauge a little bit. That way you know you're kind of over the hump. You know, if your pressure curve comes up and then down again as you depress the clutch pedal, they want you to be on the other side of the hump. That way they know you're not on the bleeding off side. Anyway, that seems to work now, and it seems to shift through the gears really nice. So what I was doing there is I have the collar shift in neutral, and I'm grabbing, you know, I'm going from reverse to high, low to reverse, and you can see the pressure dumps and then gently ramps back on. So let's see here. The manual says 1800 RPMs. I should have 170 to 180 PSI with the oil hot, which it is. It's definitely warm now after all that. So let me start that, run it up to 1800, and we'll see if we actually have that. All right, so 1800 RPMs, we have 172 PSI with the oil hot. That's really good. I know a lot of guys will have even less, and these things still run. So that's good. When we're shifting from reverse to high or high to reverse, oil pressure at the bypass valve and the accumulator housing should drop from and return to engaging oil pressure in 1.5 seconds average. If deviation from this time is observed, readjust clutch oil manifold needle valve. So that's on the other side of the trans. We haven't gotten into that, and I don't want to unless I need to. Always check clutch adjustment before attempting to readjust this. So that is the linkage down in the bell housing. Don't touch your needle valve until you're sure that that one's correct. When shifting from high to low or low to high, the oil pressure bypass should accumulator will run 170, 180 in 1 second. So we are seeing that we have a faster shift when we go high, low, low, high than we do high reverse, which makes sense. Adjust the pressure if necessary. So you would shim the pressure regulating valve to actually increase the pressure. Being that I'm at 172 and this thing's this old, I ain't touching it. That is plenty good to me. So speed of shift is important here. So you don't want a rapid shift, because then you're going to be slapping the tracks and shock loading the whole drivetrain. You don't want a sluggish shift either, because you'll just get the clutches hot. So every time you want to push into a pile and then grab reverse, it's going to, you know, slip the clutches into reverse. So you want it to be, I think John Deere uses the term snappy. You want a snappy shift, but you don't want it to be too aggressive. And that's totally like up to the operator. So let me see how this thing shifts back and forth. I'll do a little 1 Mississippi, 2 Mississippi in my head and see how that shift timing looks. 1 Mississippi, a little slow. 1 Mississippi. 1 Mississippi, 2 Mississippi. That is a little slow. That is definitely a little slow. Let's go reverse to high. 1 Mississippi. That was spot on. High to reverse. 1 Mississippi, 2 Mississippi. 1 Mississippi. 1 Mississippi. I was loving how things were going, and maybe I spoke too soon about the transmission being up to temperature, because now I was slamming this thing back and forth, you know, 50 times, just watching the pressure, making sure everything's consistent. We were doing pretty good, and then it started to act up a little bit. Like it wasn't really making full pressure as quickly as it should. And then it got a little worse, and now it seems to have stabilized. It seems to be working okay. I mean, you could use it, but it's only making like 140 to 150 PSI now. So I'm gonna pull the pressure valve, see if we can shim it, get a little more pressure out of her, and see if that'll spice up the shifts a little bit. Okay, so we've got a spring in this plug, and there's no shims in this currently, which I guess is encouraging. It's not full of pennies like I expected it to be. And I'm pretty sure I didn't drop anything. I didn't hear anything. I don't even think I want to take that spring out. I think I'm gonna put a couple dimes in here, grease them in, and stick this thing right together. I was very careful taking that off. I didn't hear a single noise, so I think we're okay. I don't think I dropped any shims. If I did, I think that is just the bell housing there. So they'll just fall into the bell housing. They'll probably be all right. But let me go check the piggy bank. No lie, John Deere had to build this to fit pennies. They fit perfect in there, like, literally perfect. So I'm gonna stick some grease on some pennies. I'm gonna drop 2 of them in here. They built this machine for cheap asses like me, for sure. Greasy penny trick. I could make a couple jokes about that, but I will be removed from YouTube promptly if I did. I really thought this was going to be a super simple video. Just adjust the clutch pedal, a couple washers under it, a couple adjustments, and boom, there we are. But unfortunately, it's not that simple right now. Looks like I got a little too excited with the double penny there. Let's pull that back apart and just use 1 penny. So for everyone's info, 2 pennies gained me 55, 60 pounds. So don't know that that's going to be the same for all machines, but if you're only needing 10 pounds, 20 pounds, you're going to want to stick to a 1 penny program. Cool, spring came out this time. I'm okay with it. That means we didn't lose our shims because she's greased in there. Put that. The good news, what we just proved, is that the pump still has a lot of life left in it. If we shim this relief valve shut, and I'm calling it a relief valve, I know that's not the right term for it, but if we shim this valve shut and the pump still couldn't make the pressure, then I'd say, yeah, we've got a massive internal leak or we have a pump issue. So the fact that she'll make that pressure on demand gives me hope that this pump has some life left in it, which is crazy with the amount of crap we pulled out of the strainer. So hopefully all the piston seals and valve bodies that are in this transmission are in decent shape as well, because I really don't want to open this. I don't want to get into this much of a project. What do we think about that? Makes about 185 in gear and 190, 192 in neutral. That's over spec. 1800 RPMs is said to be 170 to 180, so I'm a little on the high side. You know, maybe the fluid cooled down a little. Maybe I'm overthinking it. Maybe it doesn't need to be plus or minus 5. It's working as is. I think I'm going to leave it. You know, I just don't know if being 10 pounds high matters. I mean, I will go put a penny in the lathe and knock 5 thousandths off of it and make it perfect, but I don't know that that's really worth my time. I mean, I could try a dime. It's a little thinner, but I'm gonna run her a little longer at 1800 RPM, let it get really hot, and see where she settles out. All right, I'm gonna leave it there. So I've been running this thing 1800 RPMs. It's hot. I mean, I don't have a working trans temp gauge, but I can't hold my hand on this. My infrared's saying 135 on the cover. So if the cast iron's up to 135, that fluid's gotta be 150, 160. We're close to warmed up. And in gear running, we are just about 180 PSI. We get a nice 5 PSI bump when we touch the clutch pedal, then it dives off. Shift's awesome, you know, runs back and forth. I'm gonna call this one done. I really think that's the way this is supposed to work. The last thing I'm gonna do is drive this thing back and forth a little bit, see how that shift feels in real life when actually we're in gear and the tracks are getting slapped back and forth. So let's see how that feels. Guys, I realize you can't see crap in that because I'm shooting this in pitch darkness, because unfortunately that's the only time I find where I can actually get out here and get some work done with all the other things going on. This machine was very abrupt, and honestly I was afraid to shift into reverse without using the clutch when I first got it. It used to pound reverse so hard, even in neutral, even with the collar shift in neutral, when you hit reverse, it would smack the gears and just make a terrible noise. This thing shifts like butter now. So that was second gear, 2,000 RPMs. I was throwing it from high to reverse, back and forth, not touching the brake, not touching the clutch, and it is buttery smooth. It runs awesome. I'm so excited to get that straightened out. I've seen guys online, they're like, yeah, you don't have to use the clutch for shifts on these. They're made to just power shift, forward, reverse. And I was like, holy crap, who does that? This is so violent, I'm gonna end up blowing the finals out of it and everything else. But when you set it up the way John Deere intended, it's actually extremely nice. So, all in all, we fixed the clutch pedal. There's actually still a problem with the engine clutch. I think it seized to the pressure plate, but that's okay. You can actually still shift the collar shift, because if you have the HLR in neutral and you come to a full stop, and if you shift the collar shift pretty quickly, it won't bark at you, it'll just go into gear. So I can still shift gears with the engine running. I got forward, reverse, high, low. Everything works just as good as I need it to. So I'm really hype on that. This job cost 1 penny. 1 penny was all I put into it. No parts, just all labor. I got 2 or 3 hours out here playing around with it. Now that I understand how it works, it could go a lot quicker next time. So I think this is really important to do on these dozers, because you don't want to have to get into that transmission and rebuild it if all possible. So having the clutches engage quickly, have the amount of pressure you need behind them to prevent them to slip, I think it's just super important. Otherwise, not much I could say. Pretty smooth job. I didn't want to get into shimming it for pressure, but now I'm glad I did, because now I see when this thing's hot in gear, we're about 180 PSI, which is right at the high end of the spec. It works awesome. I can't say anything more. I don't have a working trans temp gauge, so I think I was only able to get this trans up to about 140 on the case. So I would assume the fluid is maybe 10, 20 degrees warmer than that. So we're getting close, but we'll keep an eye on it when I actually go push some piles with this thing. If you're an expert on these dozers, I would love to hear from you. What did I do wrong? Is this operating correctly? Is there anything I could have did better? And also, if you're working on one of these dozers, I hope you found this video helpful. I wish somebody had a video like that when I bought this, so I would know how to do this stuff. But instead, I'm just out here cranking beers at 10 o'clock at night trying to figure out how this works. So thanks for watching Spank Ranch Garage. I'll see you next time.